earlier this year we learned about quadratics that look like this. And what did we have? What did we call a vertex at the bottom?
Valley.
There's a valley, which we use one of those words. It was a minimum, right? And then if we had a quadratic that opened down, then we called the vertex a maximum. Now, the thing about polynomials is they can go on forever, right? Like a really big polynomial can have a whole bunch of like Humpty Dumptys. So let's say I have a polynomial that looks like this. Is it ever going to stop going down? Is it ever going to stop going up? No, so it technically doesn't have an overall minimum. We can never say, hey, this is the bottom, right? Or this is the top. We don't know. It keeps going forever. So we have something called a local max or min. Okay? Those are the hills and valleys within the polynomial. So it might not be the highest point or the lowest point, but it is some type of hill or valley. So you can see here in this picture, there's 2 local maxes and there's 1 local minimum. Local meaning like in the picture, right? Like kind of close to home, like right there, what you can see. So you don't need to write this down. You can maybe write these down. You don't need to copy the graph unless you really want to. This should be pretty easy. Let's do domain, because it's been a while. Does it ever stop going to the left?
No.
Is it ever going to stop going to the right?
No.
No. So domain is all real numbers. So domain is the x values. It's left and right. Range are the y values. Remember, that's bottom to top. So what's the lowest this graph will ever be?
Negative infinity.
Negative infinity. But it does have a top. What's the highest the graph will ever be?
Like 17. 16.
It's okay. You can kind of approximate. So maybe call that like 18. So do you remember how we do that in interval notation with parentheses and brackets?
Yeah. Brackets.
So I would say this is negative infinity up to 18. And I'll use a bracket to represent kind of like that solid point on the top. Now, why is the negative infinity on the left? Why isn't it 18 to negative infinity?
Lowest to highest.
Yeah, it's lowest to highest. It's number line order. So we've done this before, just as a good review. Okay, now we have to do the local maxima, or local max is what you might hear it as. So how many tops to the mountains or hills do you see?
2.
There's 2. So one of them is right here. What is that point?
0.
Left 2, up 0, right? That's the point, negative 2. We can write it as a point. And what is the other one if we have deemed that as an 18?
2, 18.
Yeah, that's okay. We can call it 2, 18. It's not a perfect graph, so we're just kind of estimating. Those are the tops to the hills, right? Now, how many minimas or mins do we have? Only 1, right? There's only 1 valley. This never stops going down, and this never stops going down. So that's the only valley, right? So approximately, what point is that?
0, negative
11.5.
0, negative. Yeah, I'm sorry. Negative 11.
If I'm being really exact, I might say something like negative 0.25, comma, negative 12-ish. It looks like it's definitely not on the y-axis. It's a little bit to the left, so we can approximate that. And then it looks like it's down about 12-ish. Easy enough?
Yes.
Okay. Go ahead and get out your graphing calculator and type in this big, ugly polynomial, starting with x to the 5th, minus 2x to the 4th, minus 10x cubed, plus 8x squared, plus 33x, plus 18. Okay, so go ahead and hit graph and see what happens.
Beautiful.
Yeah, it's actually not bad, right?
Yeah, that's great.
One thing you can try, remember I told you sometimes it works, sometimes it doesn't, is to try zoom fit. So if you go to zoom and it's actually 0, you can go up or down or type in 0. Sometimes that works, sometimes it doesn't. Yeah, it doesn't do a very good job there. We miss all the stuff in the middle, right? So I would go back to zoom 6. So I'm going to go into my window and change my Y minimum to -5 and my X min to -5 and my X max to +5. And then let's just make it a little bit taller. So I'm going to change my Y min to -20 and Y max to +20 and see if that looks maybe a little bit better. That's a pretty good graph. But we're still, it looks like there was a hill that we're kind of missing. Do you see that?
Yeah.
Like that one's probably within reach. So I'm going to change my Y max. It's a total guessing game. Just kind of feel around, see what you need to do. Y max, I'm going to change that to like maybe 50 and see if that helps. Is that not enough?
60 works.
Oh, we're so close. Actually, that would probably work, but I'll go ahead and change it to like 75.
Good job, Colin.
Graph. Now that's a really good view of the polynomial, okay? So how many x-intercepts does it look like occur? Looks like there's 3, right? So it looks like there's one here, here, and here. Do you remember how we found those on the calculator? Trace.
Yeah.
Second trace. And then which of those represents an x-intercept?
0.
0. And now there's 3 of them, so you're going to have to do this 3 times. I like to go left to right. So I'm going to move my cursor. Okay. I'm going to move my cursor all the way to the left. What's doing? And you need to go down below, right? You need to go to the left of the x-intercept, which in this case is below, and to the right of the x-intercept. So hit enter, and then guess in the middle. Ooh, it comes out perfect. It's -2. That does not always happen. So one of our x-intercepts is -2. Okay, now let's do second trace, 0. This should get pretty fast. Now you're already to the left of it, right? So just hit enter. That's why I like going left to right. And then now you need to go past the x-intercept. Hit enter again. And then guess in the middle. Oh, give me that same one.
-1. I already looked at it.
So another way you can confirm is if you guess. So trace -1 and hit enter. What should I get if it is a 0? 0, hence the name. So the other one's -1. This is another way you can do it. And lastly, we need to go way over here to the right a ways. So second trace, 0 to the left, to the right, and guess in the middle.
Why not use the table?
Now, if you ever, the table is helpful with whole numbers, but if these were increments that were not whole numbers, you wouldn't be able to see those.
Okay.
So this one, yes, you could use the table. What do you think the calculator's trying to tell you here? Yeah, it's okay to go. Your calculator's trying real hard, but it's okay to go ahead and call that 3. 2.99999. Let's call it 3. Okay.
99996.
Okay. Now, how can we tell the multiplicity without having an equation? Yeah. So the first one is going to have a multiplicity of what? 1. That one crosses. Or we really don't know for sure, but we know it's odd, right? Probably 1. What about this one that does bounce? 2 or even. And what about this one? 2 or even. They're bouncers, so we know they were even. So the only one that was definitely odd was the first one, and then the other ones were even.
Okay.
It should add up to the degree, right? So we actually do know these would be 2 if this was 1. 2 plus 2 plus 1 is 5. And the last thing we need to do is determine the max and mins, Lindsay. So how many relative or local maximas do we have here?
2.
I see 2 tops to a hill.
Yeah.
You see them?
Yeah.
One of them's right here. One of them's right here.
Yeah.
So I'm going to start on this one. Okay, I'm going to do second trace. Which one do you think we're going to use? Yeah, we're finding maxima, so hit 4. And it's the same thing as the zeros. You have to go to the left of the hill. So I'm doing the big hill right now. Left of the hill, right of the hill, and guess in the middle. Now that is not pretty. So this is a scenario in which you would definitely need your graphing calculator. So one of our maximas, we can round it to the nearest tenth. That's fine. So let's call it 1.3, 50.5. Okay, and then I'm not going to do it now, but you would do another one for the other hill, right? How many minimas do you see? Local mins? 2. There's a little valley right here, and there's a big valley right here. So let's do the big valley just to practice. Let's do second trace. What am I trying to find? Minimum. So you arrow to the right and go to the left of the valley. Go to the right of the valley. Guess in the middle. And we already actually knew that, right? How did we know that? How did we already know that valley?
X-intercept.
That was an x-intercept, right? So, and remember I've told you this before. 4.11. What do you think E means? Exponent. It's telling you scientific notation. Times 10 to the negative 10th. And what do you do when you have a negative exponent? We did this the other day. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is this number basically? It's 0. It's 0. So it is safe to call this 3, 0. Your calculator's not perfect. It tries really hard. But sometimes these weird polynomials, it just gets a little screwy. So it's safe to call that 3, 0. Okay, now the last thing here, real versus non-real. We know that all 5 of these add up to the degree. So they were all real. Okay? If there's not, that means the other ones were imaginary. So let's say it's an x to the 7th, but I only got 2 answers, and they both had a multiplicity of 1. How many of them were imaginary? The other 5. So there would be 2 real x-intercepts and 5 imaginary x-intercepts. That's how that works. I'm not too worried about that.